right, so now we're going to define certain features of relations. So a relation, we say it's reflexive if ARA is true for all A that are part of our set. So reflexive reflects back on itself. Symmetric, ARB implies BRA. So symmetric, flip them over, same thing is true. And of course, this is going to be true for all A and B in our set. Transitive is if we have ARB, that's true, and BRC. So A is related to B, B is related to C, and then that implies that A is related to C. And now we've got A, B, and C are elements of our set. So the reason that we want to think about reflexive, symmetric, and transitive is that if a relation has all three of these properties, then we say it's an equivalence relation. And back up here where we talked about equivalence classes, so we talked about these being the equivalence classes. Equivalence classes are more specifically within relations. So here we had a relation, and then more specifically, they're within an equivalence relation. Yeah, so we have equivalence classes in equivalence relations. We have an equivalence relation if these three things are true. So let's look at example 3 here and talk about why the set of all polygons, the relation being that X and Y are similar polygons. So why is this an equivalence relationship? So our Cartesian product here is the set of all polygons. Both A and B are going to be the set of all polygons. Our relation is X and Y are similar. So if we think about X are X, well, what we're really saying here is that a polygon and itself are similar. Well, of course that's true. Yeah, any polygon is going to be similar to itself. So this is true. X are Y, this implies that X is similar to Y. Well, so polygon X is similar to polygon Y. Of course that means that polygon Y is going to be similar to polygon X. So we have reflexive and symmetric, that's true. And now, if polygon X is similar to polygon Y, and polygon Y is similar to polygon Z, well then, of course, polygon X is going to be similar to polygon Z. So we've got reflexive, symmetric, and transitive. So this is an equivalence relation. To test equivalence relations, you have to show that all three of these things are true.